Hi everybody. Completing the square. When to use it and when not to use it, because there is an alternative in the quadratic formula for a lot of people. And a lot of people do lean towards a quadratic formula, so you would say, well, why should I even bother with completing the square? Well, first of all, with completing the square, you're going to need to know it when you talk about finding equations of circles, which is another video for another time if you stick around watching my videos. If you're my online students, I highly recommend watching my videos. There is a time when I would say, yes, complete the square, and there is a time when I'd say, yes, use the quadratic formula. When would I recommend which? It depends on what you've got for your setup. If your leading coefficient's a 1, which it is here, and if the coefficient next to your variable here is an even number, then I would use completing the square. And in my part 1 video, that's what I did. I think I had a 8 here is an even number. Now I do have an odd number here. I'm going to go ahead and do this by completing the square, but hopefully when I do this, you'll get an appreciation as to why the quadratic formula might be the better option for you. So what I'm going to do here is I'm going to subtract my 2 to the other side, because when you complete the square, your leading coefficient needs to be a 1. And everything, all your terms with a variable in it need to be on one side. Everything without the variable in it needs to be on the other side of the equal sign of the equation. Alright, so if you watched part 1, you know that we're going to take the coefficient in front of the variable that's not squared, and we're going to take half of it, and then we'll square it. Well, half of a -5 is a -5 halves, and when you square it, you'll have 25 fourths. Okay? So I'm going to add that 25 fourths to both sides of the equation. So y squared minus 5y plus 25 fourths is going to equal a -2 plus the 25 fourths. And hopefully right away you can understand why I probably would have gone with the quadratic formula. Because I had an odd number here, it's going to introduce a fraction. And fractions aren't exactly the best things to work with, as I'm sure you guys can attest. Granted, with a quadratic formula, you have a fraction to work with, but it's a little more friendly because of the steps involved. A lot of people like the quadratic formula and whatnot. So I'm going to write this as -2/1. My left-hand side here is a perfect square trinomial. That was the whole purpose of using the completing the square approach here. And what that perfect square trinomial, and what that, perfect square trinomial is, back it out. If this side here on the second term is negative, plan on this guy being negative, so it's going to be y minus. And as for what's going to go in here, it's always the square root of this number now. So the square root of 25 fourths, we see it here, -5 halves. And on the right-hand side, I'm going to need to add those guys, so we need a common denominator of a 4. So we're looking at -8 plus 25. -8 plus 25 is a positive 17, right? So 17 fourths is what we're looking at on the right-hand side. Alright, now we're going to square root both sides. And I forgot to mention this in my first video, part 1, that at this point I'm going to use this thing called the square root property. I'm going to square root both sides. So we're looking at y minus 5 halves equaling plus or minus the square root of 17 fourths. Now the square root of 17, that's not a perfect square, so I'll leave it as the square root of 17. But the square root of 4 is, that's 2. So my right-hand side is going to be plus or minus the square root of 17/2. And now I'll add my 5 halves to both sides. So we've got 5 halves plus or minus the square root of 17/2. You can write your answer like that. There's no I in this thing, so I don't have to read it in complex form or whatever. Meaning, if you want, since I already have a common denominator, you can write this thing as one fraction. 5 plus or minus the square root of 17/2. Which one's better? I don't know if it matters in this case. I think you're probably fine either way. So there you go.